Myself Ashutosh Khatri, first year undergrad at IIIT Vadodara ICD campus. Today I am going to talk about wind power farms. What are wind power farms? What are its uses? And also take an example of a largest power farm in the world. That is Yukon Wind Power Base, wind power farms, energy harnessing from the wind. So these are the table of contents. First, we are going to talk about wind power farms, then Yukon base, how it works, how the wind power is generated from the wind, and at last, criticism. First, wind power farms. General idea of what wind farms are and what are its types. Growth of wind power plants. In recent years, there has been a rapid growth in the number of wind power farms across the world, underpinned by technological advancements. Globally installed wind generation capacity onshore and offshore has increased by a factor of almost 75 in the past 2 decades, jumping from 7.5 gigawatt in 1997 to 564 gigawatt by 2018, according to IRENA. After the wind turbines are built, operational costs involved in maintaining wind power plants are low, and they are generally considered to be relatively cost effective. Wind farms can also be constructed on agricultural lands without causing any interruption to cultivation activities, but the maintenance of the wind turbines may vary, as some need to be frequently checked and need power projects typically require huge capital expenditure. Now we're gonna talk about design and location. Location is critical to overall success of a wind farm. Additional conditions contributing to a successful wind farm location include wind conditions, access to electric transmission, physical access, and local electricity prices. The faster the average wind speed, the more electricity the wind turbine will generate. So far, faster wind are generally economically better for wind farms development. The balancing factor is that strong gusts and high turbulence require stronger, more expensive turbines. Otherwise, there is a risk of damage. The average power in the wind is not proportional to the average wind speed. For this reason, the ideal wind condition would be strong but consistent winds with low turbulence coming from a single direction. Mountain passes are ideal location for wind farms. Under these conditions, mountain passes channel wind blocked by mountains through a tunnel-like pass towards areas of low pressure and flatter land. Passes used for wind farms like the San Gorgonio Pass and Altamont Pass are known for their abundant wind resource capacity and capability for large-scale wind farms. Design and location. A major factor in wind farm design is the spacing between the turbines, both laterally and axially, with respect to the prevailing wind. The closer the turbines are together, the more the upwind turbines block wind from their neighbors. This is called wake effect. However, spacing turbines far apart increases the cost of road and cables and raises the amount of land needed to install a specific capacity of turbines. Closer spacing is possible depending on the turbine model, the conditions at the site, and how the site will be operated. Airflows slow down as they reach an obstacle, known as blockage effect. As a result of these factors, turbine spacing varies by site. Generally speaking, manufacturers require a minimum of 3.5 times the turbine's rotor diameter of clear space between each adjacent turbine's respective spatial envelope, reducing available wind power by 2% for the turbines in front of other turbines. Often in heavily saturated energy markets, the first step in site selection for large-scale wind projects before wind resource data collection is finding the areas with adequate available transfer capability, that is ATC. ATC is the measure for the remaining capacity in a transmission system available for further integration of two interconnected areas without significant upgrades to existing transmission lines and substations. Significant large equipment upgrades have substantial costs, potentially undermining the viability of a project within a location, regardless of wind resource availability. Once a list of capable areas is constructed, the list is refined based on long-term wind measurements, among other environmental or technical limiting factors such as proximity to load and land procurement. So basically, there are two types of wind power bases: onshore and offshore. Onshore are which onshore wind energy is the power that's generated by wind turbines located on land driven by natural movement of the air. And offshore wind farms generate electricity from wind blowing across the sea. They are considered more efficient than onshore wind farms. Onshore wind farm has been capturing and converting wind power in some form since 1880s to make corn or dry pumps. But the opening of Delabole wind farm in 1991 heralded the commercial era of onshore wind in the UK. Today there are more than 1500 operational onshore wind farms across the Great Britain, generating over 12 gigawatt hour of electricity for the national electric system. In 2020, onshore wind contributed 11% of the UK's electricity needs, with a total 14.7 terawatt hours, generated more than enough to power 18.5 million UK homes for an entire year. Offshore, thanks to the higher speed of winds, greater consistency, and lack of physical interference that the land or human-made objects can present. The UK is the world leader in offshore wind. As of 2020, there are nearly 2,200 wind turbines across of 35 offshore wind farms off the coast of England, Scotland, and Wales. In the same year, they produced 40.7 terawatt hour, up 27% from 2019, and contributed 13% of the UK's electricity needs. So there are basically two types of wind turbines. First is horizontal and second is vertical. Horizontal. Most commonly they have three blades and operate upwind with the turbine pivoting at the top of the tower so the blades face into the wind. The other are vertical. These are omnidirectional and comes in various varieties. One such can be seen in the pic. These turbines are omnidirectional, meaning they don't need to adjust it to the point into the wind to operate. Next is Jukan Base, the world's largest producer of wind energy. Ganshu Wind Farms. The Ganshu Wind Farm Project or Jiuquan Wind Power Base is a group of large wind farms under construction in western Ganshu province in China. The Ganshu Wind Farm Project is located in desert areas near the city of Jiuquan, in two localities of Gazhou County and also near Yumen City. In the northwest province of Gansu, which has an abundance of wind, the complex is operating at below 40% utilization of the current 8 gigawatt with a planned capacity of 20 gigawatt. Overview: the largest onshore wind farm is the 7.96 gigawatt Ganshu wind farm project constructed in the Gobi Desert near Jiuquan in Gansu province. It is considered to expand to and reach for a total capacity of 20 gigawatt thanks to an investment of 17.5 billion dollars to construct 7,000 wind turbines. The wind farms in stretching over Inner Mongolia, Jiuquan, Jiangsu, Shandong, Hebei, and Xinjiang province in Gansu, China. The Gansu wind farm project is composed by several large wind farms. Some of them operation and some more under construction. The whole project sees the involvement of more than 20 developers. The wind farm is at an altitude of around 1700 meters in the Gobi Desert, where the average wind speeds at 90 meters above the level are nearly 7.9 meters per second. The latest news sees at least 40% of the power produced by giant of wind parks to be wasted, as energy demand has been undercut by the economic slowdown in the region. Demand and utilization. With local government favoritism toward coal and inadequate long-distance transmission capacity, Ganshu now has some of the highest rate of underutilization in the wind sector in China. National Energy Administration statistics showed 39% of wind capacity in 2015 in Jiuquan was wasted. As of 2017, is far from far from full capacity, and the wind farm is producing less than half of its full potential. The two main reasons why this is happening is that Ganshu is located far from the major Chinese cities and that there is a lack of demand for wind energy in China. Below are few pictures of the Ganshu wind farms and wind turbines in Ganshu. Now we are going to talk about how it works, how the turbine is how the turbine generates energy from the wind. all about how the energy is harnessed from wind. How does a wind turbine works? Let's start with the visible parts of the wind farm that we are all used to seeing, those towering white or pale grey turbines. Each of these turbines consists of a set of blades, a box inside them called a nacelle, and a shaft. The wind, even just a gentle breeze, makes the blades spin, creating kinetic energy. The blades rotating in this way then also make the shaft in the nacelle turn, and a generator in the nacelle converts this kinetic energy into electrical energy. Wind turbines do tend to be either white or very pale gray, the idea being to make them as visually unobstructive and as possible. There is discussion about whether they should be painted other colors, particularly green, in some settings to help them blend in with their environment better. So, this is a diagram which shows how industrial wind turbine components work. How a wind turbine creates electricity. The core component of wind turbine is the generator, which converts mechanical energy into electricity. We have known since the early 19th century that if you turn a conductor in a magnetic field, then it creates electricity, according to Faraday's law. So the wind provides the movement and torque, and the generator does the rest. For an industrial scale turbine, like the ones you see on wind farms, there will normally be an emitter that is attached to a control panel. The turbine is activated at wind speeds of over 8 miles per hour, but the machine is shut off with speeds in excess of 55 miles per hour to prevent damage. The gearbox is used to change the slow motion we see from blades turning to the faster motion of the axis, which actually drives the generator. This is one of the most costly parts of the wind turbine, changing speeds of 30 to 60 revolutions per minute into thousands revolution per minute. It's one of the areas that researchers and developers are looking to make their more efficient so that a greater current of electricity can be produced at slower speeds. Now, let's talk about criticism. Environmental effects of power plants. So this is the overview how the wind power farms affects human health, environment, radio reception interference, and agriculture. Human health. There have been multiple scientific peer-reviewed studies into wind farms noise which have concluded that infrasound from wind farms is not a hazard to human health, and there is no verifiable evidence for wind turbine syndrome causing vibroacoustic disease. A 2007 report by US National Research Council noted that noise produced by wind turbines is generally not a major concern for humans beyond about 800 meters, zero point 0.5 miles. A 2014 paper suggests that the wind turbine syndrome is mainly caused by nocebo effect and other physiological mechanisms. Low frequency vibration and its effects on humans are not well understood, and sensitivity to such a vibration resulting from wind turbine noise is highly variable among humans. There are opposing views on this subject, and more research needs to be done on the effects of low frequency noise on humans. Next up is environment. The environmental effect of wind farms is minor compared to that of fossil fuel power plants. Wind power consumes no fuel and emits no air pollution, unlike fossil fuel power sources. The energy consumed to manufacture and transport the materials used to build a wind power plant is equal to the new energy produced by the plant within a few months. Next up is radio reception interference. There are also reports of negative effects on radio and television reception in wind farm communities. Wind turbines can often cause terrestrial television interference when the direct path between television transmitter and receiver is blocked by terrain. Interference effects become significant when the reflected signal from the turbine blades approaches the strength of the direct unreflected signal. Reflected signals from the turbine blades can cause loss of picture pixelation and disrupted sound. There is a common misunderstanding that digital TV signals will not be affected by turbines. In practice, they are. Last is agriculture. A 2010 study found that in the immediate vicinity of wind farms, the climate is cooler during the day and slightly warmer during the night than the surrounding areas due to the turbulence generated by the blades. In another study, an analysis carried out on corn and soybean crops in the central areas of United States noted that the microclimate generated by wind turbines improves crops as it prevents the late spring and early autumn frosts, and also reduces the action of pathogenic fungi and that grows on the leaves. Even at the height of summer heat, the lowering of 2.5 to 3 degree above the crops due to the turbulence caused by the blades can make a difference for the cultivation of the corn. So this is all about the wind power bases. Thank you for listening. This is the citation of the sites from which the information is taken.